Hi, Mr. Zapone here, and we are going to solve another torque problem. This is identical to the last problem we solved, except now we're going to factor in the idea that the board, the seesaw itself, does have mass and generates torque. So Fred weighs 1,200, Barney weighs 900 newtons. They are on opposite ends of a seesaw board that is 4 meters long. Where would the fulcrum need to be so that they balance perfectly? Assume the board weighs 150 newtons. Little grammar error there. So we're going to solve this problem exactly the way we did the last one, except we have to factor in an extra torque because we have the center of mass of the board. So again, torque on the left equals torque on the right. We have 1,200 over here, 900 there. We have to figure out where to put the fulcrum. We know that Fred is heavier, so we're going to have to put the fulcrum closer to him so that way Barney can generate more torque to balance Fred's. And what we did was we defined the distance from first, this also, we have a force down, 150 newtons, right? The center of mass, we're going to assume the board is uniform. So the center of mass is directly in the middle of the board. So there are actually two torques on the right-hand side of the fulcrum. So there's two things that are going to make them generate. Or there's two things that are going to generate a downward torque. So to get the torque on the right, all you're going to have to do is simply add both torques together. But now we have three unknowns. We're going to call the distance from Fred to the fulcrum x again. We're going to call the distance from Barney to the fulcrum. This is Barney to the fulcrum, all the way from here to here. From this little triangle point in the middle to Barney is y again. Remember, we got rid of that? What we are going to do is call this next distance, well, naturally we have x, we have y. We're going to call this z. Z is the distance from the fulcrum to the center of mass of the board. And we're going to have to do the same thing. We're going to have to write z and y in terms of x, so we have only one unknown in this problem. Let's deal with z first. First of all, we're going to do what we did before. We know x plus y is equal to 4. The whole thing is 4. This distance right here is x to the fulcrum, and from the fulcrum all the way over here is y. So we know that x plus y equals 4. We can do that. Same thing we did last time, but we need to figure out what z is. And of course, z goes from here to the middle of the board. Well, the middle of the board is 2 meters. It's 4 total, so half of it is 2. So really, x plus z equals 2. Let that sink in. Let that sink in your head. Half of this board is 2 meters, and x plus z gives us half the board. So x plus z is going to be 2. All right, so z plus x, or x plus z, is equal to 2 meters. We also know that x plus y, this distance plus the whole distance from the fulcrum to y, is equal to 4. So we can rearrange both of these terms. Z equals 2 minus x, and y equals 4 minus x. Now that we've done that, we can actually solve this problem. Torque on the left equals torque on the right. So we got to balance our torques. And we know force times distance on the left equals force times distance on the right. Now, what is your torque on the left? Well, it's 1,200 times x. Right? That's your force times distance. That's all there is. What is it on the right? Well, we have two separate torques, which is why we have two terms here. This term right here is the torque due to the board. The board has a force of 150. What's its value? Well, its value is z, but we don't want to plug z in there. We know that z equals 2 minus x. And we need to add this torque to the torque of Barney, because Barney and this torque are on the same side. Barney, of course, has a force of 900. And what's Barney's distance? Well, y is actually equal to 4 minus x. So we basically set this problem up like this. Torque on the left equals torque on the right. We have to add the two torques together on the right. That's what this is. This is the torque of the board. This is the torque of Barney, and we're adding them together. But we have to be clever before we can do that. This is x. Barney's distance is y. And the distance from the fulcrum to the midpoint, or the center of mass, about which the board will rotate. Remember, all objects rotate around their center of mass, is z. So that's how we basically solve this problem. And you end up with x equals 1.73 meters. I think that was it. So keep that in mind. If you have questions, please don't hesitate to email me. Good luck with your homework.